Question number 2 is a Poisson distribution sum. The number of defects per meter, this information is very important, in a roll of cloth has a Poisson distribution with mean 0.25. That means lambda equals to 0.25. So the first question is find the probability a randomly chosen meter, that means this meter and this per meter is the same unit, of cloth has one defect. Now this one defect, that is the random variable. So this is random variable, so one defect. So first of all, what we have to do is we have to define the distribution. So let's define the random variable first. So number of defects, the number of defects in a roll of cloth, it has to be properly defined in context. So x is the number of events. What is the event? Number of defects in a roll of cloth. So that's the random variable defined. Now we define the Poisson distribution, which is 0.25 is the value of lambda. Now remember, the random variable is 1. So it has one defect, that means x equals to 1. So what we have to do, if we want to use the table, we can write it as x is less than or equals to 1 minus probability of x is less than or equals to 0. This is the same as probability of x equals to 1. Remember, the table is cumulative. Now this is the Poisson distribution, is the cumulative Poisson distribution, and the values of lambda are in this first row. If you pay attention, you would see it starts from 0.5 and we don't have 0.25 in the Poisson distribution table. What does that mean? It means we have to use the formula. So we cannot use this. So let me remove this. So let me write down the formula over here. If we have a Poisson distribution where the mean is lambda, then we have x equals to a equals to e to the power minus lambda, lambda to the power a divided by a factorial. Factorial means you keep multiplying backwards till you get 1. So what we have over here is e to the power minus 0.25 multiplied by 0.25 to the power 1 divided by 1 factorial. So if we use the calculator, so this is going to be e to the power minus 0.25, that is multiplied by 0.25 to the power 1 is 0.25 divided by 1 factorial is 1 times it itself is 1, so it would be 1, so it will basically 0.1947. Question number B. The total number of defects in a randomly chosen 6 meter. Now notice that the question was per meter. Now we have 6 meters, so we have to change the definition of the random variable. So this would be number of defects in a roll of cloth per 6 meter. So previously this was per meter. Now this would be per 6 meter. So the value of the mean 1.5. So lambda is 1.5. So now we have to find more than 2. So probability of x. Now one thing is very important. If I write here x per meter, I cannot write here x all over again. The random variable has to be changed because the value of lambda has changed. So let me change this. Okay, now this should be y. So more than 2, so y is greater than 2. So remember, this is discrete. So more than 2 means 3. So 1 minus probability of y is less than or equals to 2. Remember, always use a number line if you're not clear about this. Greater than 2 means 3. So what we need is 3 or more than 3. But if we subtract from 1, what we need to remove is 2, 1 and 0. So it means 1 minus probability of y is less than or equal to 2. So now 1.5 is in the table. Let's look up the table. So 1.5 is right over here. You have to be very careful about looking up the table because you might miss a block and see the other block. So use a transparent scale for that. So we need less than or equal to 2. So it would be this one. If we take a look over here, 0.8088. So this is going to be 0.8088. 1 minus 0.808. So 1 minus 0.8088 is 0.8088, 0.1912. The final question is, a tailor buys 300 meters of cloth and they have mentioned approximation. That means something is going to happen for which we cannot use the Poisson distribution anymore, because the Poisson distribution has some sort of an elastic limit where after that it snaps. You cannot use the distribution anymore because the lambda has to be up to 10. If the value of lambda is greater than 10, then we have to use approximation, meaning we have to use another distribution for finding the same probability. And that distribution is known as normal distribution. Normal distribution, as you remember from S1, it has two parameters. It has mean and it has variance. And we can find the mean or expected value as lambda because the Poisson distribution has the mean as lambda and the Poisson distribution has variance also lambda. So that would be the same mean and variance for the normal distribution. So let's take a look over here. So this would be question number C. First of all, let's define the Poisson distribution. Always start from the original distribution. So x and y has been used. Z cannot be used because we use that in standard normal distribution. So let me use the letter A. So it's the number of defects in a roll of cloth per 300 meter. So let's see what the value of lambda would be. If you multiply 0.25 into 300, we get 75. So this is going to be 75. Of course, it is more than 10 and it's not in the table. So we have to use another distribution. But before that, let's see what is the probability. Less than 90 defects. Remember, defect is the random variable. So we have to find the probability of A is less than 90. Of course, this cannot be done using the table of Poisson distribution because the value of lambda is more than 10. So what we do, we use the normal approximation. So using normal distribution as an approximation. So what we do here, first of all, we have to find the value of mean. So mean is the same as lambda and variance is also the same as lambda. Both are 75. So that makes the normal distribution. Let me use another alphabet. I cannot use B because binomial distribution uses B. Let me use the letter C. So the normal distribution has mean 75 and variance 75. We don't have to give here square because it is already sigma squared. Standard deviation whole square is variance. So what we have over here is probability of C is less than 90. Now let's talk a little bit about continuity correction. The concept of continuity correction is that when you have a discrete distribution like Poisson distribution and when you convert it into continuous distribution like normal distribution, you have to do something to the random variable. The random variable has to go through continuity correction. And this is how you do it. The first thing that you do is you make this equal to. So you have to make this as C is less than or equal to 89. Less than 90 is less than or equal to 89. Now let's do So 89. So this is the value of when we are writing it as equal to, and less than means in this direction. So the continuity correction would start from here. It would be 89.5. So it would be probability of C is less than. Now the continuity correction has been done. We don't have to write the equal to sign anymore. If you write even then, that's not a problem. 89.5. The next thing to do would be to make it unit free, what we call the standard normal distribution. What that means is that when we have a distribution like normal distribution, we have to convert this into a unit free distribution which has a mean of 0 and standard deviation of 1. And for that we have to use the concept of z-score. Z-score equals to random variable subtract mean divided by standard deviation. So that is the rule for finding out the z-score. So for z is normal distribution with mean 0 and variance 1 square, it would be probability of z is less than 89.5 minus mean is 75 divided by square root of 75. So now we can do the calculation. So probability of z is less than, if we calculate this, so it becomes 89.5 minus 75 divided by square root of 75, and the answer is 1.674. So 1.67. Now we have to look up the normal distribution table. So this is the standard normal distribution table and it is in cumulative. That means everything is less than. So we have to look for 1.67 under Z. So this is 1.67 and the probability for 1.67 is 0.9525.